Hey, it's Seth. Before we get started, I want to take a quick moment to mention a way you can support the Concrete Logic podcast. Whether you're looking to expand your concrete knowledge or want to keep the show going, check out the Concrete Logic Academy at www.concretelogicacademy.com. You can always make a donation directly at www.concretelogicpodcast.com. Any amount helps, and we truly appreciate your support. Now let's get into today's episode. And welcome to another episode of the Concrete Logic podcast. And today I have Lee Thrasher with me. He is a representative for, is it CTS?
CTS Cement, yeah.
All right. And he is our resident expert today on shrinkage compensating concrete. So we're gonna, there's four things that we're gonna teach you today. What exactly is shrinkage compensating concrete, and how does it differ from traditional concrete? We're also going to explain some of the common challenges shrinkage compensating concrete helps address in terms of cracking and long-term durability. We're going to cover how ready-mix producers and contractors incorporating shrinkage compensating concrete into their projects today, and what's the impact on construction timelines and cost. And lastly, if we don't run out of time, we're going to look ahead and see how shrinkage compensating concrete is evolving as a material, and if there's any exciting developments on the horizon. All right. And with that, you can tell us a little bit more about yourself, or we can roll right into explaining what is shrinkage compensating concrete.
I certainly love talking about concrete more than myself, so let's just roll right into the concrete part. That's all right. That sounds good.
Yes, sir. So what our first thing here is what exactly is shrinkage compensating concrete, and how does it differ from traditional concrete in terms of performance and durability?
That's a great place to start, because that's often the conversation we get into, because folks, when they hear shrinkage or drying shrinkage or overcoming those things, a lot of them go right to shrinkage reduction, because shrinkage reducing admixtures is what a lot of people are more familiar with, simply from the brand recognition, name recognition that's out there and more commonly used. However, shrinkage compensating concrete does exactly what it says it's going to do, same as those do exactly what they say they're going to do. Shrinkage compensating is typically done with an expansive component on the front end, where the initial volume of the concrete expands, laboratory expansion at the early age, to offset that eventual drying shrinkage. Concrete is always going to have some drying shrinkage element to it. What we do with shrinkage compensating is we just make sure you have a higher initial volume that you start with, so that you end up at a little bit of a residual expansion or net zero volume change.
You make that sound so easy, Lee. I mean, how is that?
Yeah, it is easy. It's the best easy button for long-term durability and dimensional stability you'll ever get, But, some things that are, out there, you can find an ACI 223, and it talks about several different materials that are used that are expansive materials. At CTS Cement, we're really proud, and we obviously are known for Type K and Type K cement. And what we use today is the component with a K. And all of that is in honor of Professor Klein, with a K, who worked with our company founder, Ed Rice, back in the 60s to develop what is known today as Type K cements. There were expansive things that are out there in that chemistry, but it was an adjustment to the chemistry of typical Portland cement so that you would have that early age expansion. Typical blended in Portland cements today, they are at their highest volume actually when they're in that truck or when they're in their fresh properties. As they lose that water, they are going to shrink. It happens, and that chemical reaction takes place. It consumes volume, and it's going to shrink. So Ed Rice wanted to overcome that. He wanted to find a way to make cement better and have a better material to work with. So he worked with Professor Klein, and they created Type K cement and went on to do a lot of other things with calcium sulfoaluminate cements. We've got several different brands under CTS banner today. But the component is what we use today, or Type K cement, either one. Those are two different things we provide today to provide shrinkage compensating concrete. So the material is used as a cement replacement for Portland, whether that's replacing all of the Portland in a mix with a Type K cement that meets ASTM C, or we do it with the component of the material, like you would use with any other SCM dry powder. Works to a silo, goes in a percentage replacement. The Type K is used at a 15, 18% or so, give or take, replacement there that we're replacing with that local Portland. so that we're only manufacturing and shipping across great distances the expansive material. And that will allow that local mixture to then become the type K shrinkage compensating mixture that expands at that early age. And so the general process is it'll expand in that early age, typically somewhere between 0.04 and 0.08%, just to offset that drying shrinkage, like I said. It'll happen in the first 2 or 3 days. Under wet cure, we typically wet cure for 7 days. And once you remove the wet cure, then that material is allowed to go through the typical drying shrinkage and get back down to net zero. And then, unlike a SRA, once it reaches that stability, it's stable for the life of the structure, for the life of the concrete. It does not undergo any other volume change characteristics other than temperature. It's a mouthful.
Yeah. So it's an SCM. So this is being done at the ready mix producer at their facility, right? That's where the mix.
Yeah, you can. That kind of gets into, like you mentioned, how's it used today with contractor ready mix producer. Obviously, ready mix producers like to have the majority of that quality assurance and quality control at the plant. So they are running it through their plant process in the truck. The material shows up ready to use. There's plenty of the proprietary systems, that we talked about, or the guys that are doing the slab design, and they're providing their version, their brand, their deliverable of that high performance floor. And a lot of those projects they will dose on site, whether that's, adding the raw material, putting it into a slurry, or they have some of them have pre-mixed bags and a couple of different things that go with it to put it in at the job site from a base mix design, mix it up a little bit there, and then they're off to the races in that method of delivery. So it's really either or, whatever's best for the project. We'll do whichever way is best for the project as a whole.
Oh, okay. But not at the cement manufacturing facility, right?
That's only if we're making a type K cement.
That's where you you produce that, but you're not like getting involved where after the clinker's made and then they're doing grinding and mixing in that second part of making cement.
Well, that we are a cementitious product, so we are made at the mill. So it is
okay.
Yeah, but calcium sulfoluminate cements. I need to sip water if I'm going to say that again.
Yeah. All right.
Yeah. So where you've got Portland cement, we are a calcium sulfoluminate cement.
Okay.
So when it's made at the mill, think of it this way. This is the way Susan Foster explains it. I love it because it really made sense to me. If you think of that clinker material that we make as a cocoa bean, well, then if you grind and process that cocoa bean in one manner, you get hot chocolate powder, right? And you just simply add water and you've got instant hot chocolate. That's our rapid set version of calcium sulfoluminate cement. So it's ready to go in the bag. It's a rapid set, rapid repair. We say mix with water and land a plane in an hour. We get 3,000 and 4,000 plus strengths very, very quickly. The other way you take that same cocoa bean and grind it and process it, you have the chocolate powder like you use to make a cake. And so you need the other ingredients of that cake and time and heat in an oven to make the final product. It's still a great taste of chocolate, right? It's just two different products ultimately with the same raw ingredient. So at the mill, we're making that raw clinker.
Got it. All right. How many? Well, I think we could go down a rabbit hole there, but I'm going to try to keep us on task.
Yeah.
All right. So let's go to, can you explain some of the common challenges shrinkage compensating concrete helps address, particularly in terms of cracking and long-term durability?
Absolutely. So we can virtually eliminate dry and shrinkage cracking. I mean, we are taking care of that expansion so that we're offsetting those forces. It still happens. And so if you don't engineer and design it properly, and we do say it's engineered expansion, it's just not running wild. There's a lot that goes into it, and it's definitely controlled. And we work very diligently to make sure on the testing on the front end that we've got that correct so that we're exhausting that reaction so you stay above net zero. But if it's not done correctly, you can go below net zero and you will still have drying shrinkage that will occur. But other than that, our goal is to eliminate drying shrinkage completely. You still have to protect yourself in the process in the plastic state against plastic shrinkage cracking. And of course, if you've got things like settlement and other elements that can, crack concrete, we're not going to somehow modify your subgrade. with fresh concrete. But other than that, you can have dimensionally stable. And we follow ACI 223 guidelines. So we're typically starting our joint spacing at 150 feet, but we've done projects. I was just looking at one in history here in Atlanta. We did 340 feet on exterior paving.
Wow.
And some of the joint spacing on that. We've done plenty of projects where we're using a 3-to-1 ratio. And got plenty on the ground that are a little bit better than that, with just some longitudinal axis reinforcing added in to control that a little bit better against the curl. But in most applications, you don't have dry and shrinkage cracking. You don't have curl. Creep is virtually eliminated as well. So outside those environmental conditions after the concrete's in place, the forces of the concrete itself are managed and engineered right out of there. So obviously you have fewer joints, less maintenance. You don't have the curl, so you don't have that differential movement a lot of times that you would get that would increase settlement and create cracking and things like that. So as long as the best practices are followed and everything's isolated and lets it do its thing, it's very stable for the life of that concrete. And because we're handling expansion by creating ettringite crystals in that void space, the permeability and absorption is virtually nothing. We make a very dense material after that initial curing period. So things that would typically attack and degrade that concrete, the vast majority of those things happen through permeability and happen through penetration. Water carries a lot of bad things, chlorides and sulfates and acids and things that are all in liquid state that get down and permeate into the concrete. Well, we don't let that happen either. So we're providing a great, great finished surface. And a lot of the contractors that are out there that do shrink concrete for industrial floors, manufacturing, storage, things like that. And even in areas where we're the basin slab in a sludge basin, or we're doing containment walls for liquid containment, things like that, you see a much better life cycle cost because you have less maintenance and you have less openings and penetration points as far as joints go in that initial construction. So you get a great offset of the cost in that.
Is water cure just mandatory to make it work?
Well, water curing is always the best thing for concrete anyway.
Yeah.
Certainly in the areas where it's cold climates and things like that are elevated, it becomes, a constructability thing that we really got to look into and address. But there's great products out there today with some of the blankets and things that can go down that absorb that water on one end and maintain that impermeable surface on the other side. The biggest thing is typically expansive materials consume much more water than typical Portland cement does or blended cements do. We're a better utilization of water because we're filling that void space with more product, more things that are reactive. So it needs every bit of that mixed design water. Not so much as it used to be in the past, where you really had to increase the water cement ratio and you really had to watch it because the materials would really, really significantly drive water demand. If you look up a lot of the literature from years gone back, you'll see that. But with today's component materials, that's very, very manageable and very much under normal conditions. So what we got to do is just make sure we have that 100% relative humidity so that the engineered side of the process, of the design criteria to make sure you get what you're expecting happens. Having 100% relative humidity guaranteed on all aspects of that surface, edge to edge, corner to corner, is the only way you're going to get that assurance 9 times out of 10. And we're working on things but it's down the road.
Yeah. You're saying working on things that would not require the wet curing?
Or shorten the timeline. 223 right now is 7 days. And there's plenty of folks doing some research and, trying to figure out with newer materials that are on the market today, how can a combination of things or how can things work to try and reduce that 7-day timeline, or that are more appropriate in cold climates where you're going to have maybe great for placing the slab that day, but you're going to get down to freezing overnight. And that's certainly some safety issues and things like that. You had a big old frozen slab. Trying to figure out the best way to maintain a wet cure environment without a flooded 7-day slab is on the horizon, I think, down the road.
So that's perfect. That kind of rolls us into the next item was, talking about construction schedule and cost and how this impacts that. So first of all, it sounds like you got a plan for a 7-day wet cure. Is there what other things that you got to consider?
So whoever your supplier is, and we certainly do it, we get involved early on a project to coordinate between the ready-mix producer, the place and finish contractor, and then if it's a different entity, that general contractor that has the site control, and really get everybody on the same page as to what that process looks like. So we're huge proponents of pre-construction meetings as well as pre-pour meetings. And at pre-construction, we're going to be reviewing the design and details and layout of that joint layout. The trend here lately has been to be able to, just about every project has the ability to go jointless if the producer can provide the volume of concrete. So whether we're sticking with the slab thickness or we're thinning the slab, a lot of times that square footage falls within the joint spacing we can accommodate there. Might have to have a single saw cut or maybe a pour through armor joint or something like that. But in a lot of cases, we're utilizing the placement schedule as the joint layout. So you certainly have the time of once you get the wet cure down, you're done. The guys aren't there staying to saw cut and things like that. And then depending on how you do, your panel layouts and things, we can typically, if you've got a larger project that may have, for example, one I talked about last week with a friend of mine who was 16 placements, and with our schedule, they could cut it down to 12. So being able to reduce the overall placement time. In most cases, we can find a way to offset the delay you might have with the wet cure. And really, if you've got multiple placements, you're kind of offsetting those anyway. You want to have at least a 72-hour window before you place fresh concrete against freshly placed, something that was a recent slab that was placed. You're going to isolate it if it's existing concrete, like an expansion of a building or something like that. But you don't checkerboard it necessarily. You just stagger the placements. When we work with folks to do those different layouts to make sure it's going to fit, one of the areas where we're seeing certainly an increase in shrink comp concrete is where you've got the high rack systems or automated systems and things like that. And that joint placement becomes a lot more critical. So we can work, especially being able to do a different aspect ratio, we can work to kind of shift those elements around, move it in blocks and squares, rectangles, to really fit best for what those travel aisles need to be, what that pathway for the automation equipment needs to be, and things like that. So all those elements do play into just helping the overall constructability for sure.
Yeah. And I would imagine it helps with the FFFL numbers as well. Is it easier for the guys to finish?
I want to say what I want to say. In today's world, absolutely. The concrete that I've seen lately is some of the best and the creamiest I've seen. I don't know if that's a result of it just makes really good concrete and folks are struggling with concrete that's not the same as what it used to be. So they're having to already adjust. But just the nature of the way shrink comp concrete works, it is a very it's a very high quality material. Your everyday run-of-the-mill combination of powders that are out there. So they do see a better performance, and we can do a lot to help with giving a predictable set time. You typically have a less bleed with shrink comp concrete than regular Portland mixers. Oftentimes it's just a nice sheen. You really don't get bleed because we're consuming that mixed water, like I said. So a lot of guys that have done it really, really enjoy finishing shrink comp concrete compared to the rest of the building, for sure.
Yeah. I want to go back to talking about the amount that you replace of today's cement versus what you guys did before. So just put a mental note there. Mm-hmm. But I want to make sure we address the cost of this, compensating, shrinkage compensating concrete versus traditional concrete. I imagine it's a little bit more costly, but these are specialty floors that you're working on, heavy industrial manufacturing. So these are clients that need a high, I don't want to say high dollar, but a high value, high value floor. Is that right?
Yeah, high performance, high value floor, for sure. I like to tell people, it's one of those things where when we get the phone call, somebody just making a general inquiry, we can figure out real quick, you either need it or you don't. If you don't need it, then put the work on us to justify it and show you how it can work, because you can actually apply shrinkage compensating concrete in a multitude of building elements, not just slabs. That's the world where most of it, lives today and what people know it. A lot of that's due to the proprietary branded systems that are out there, and that the nature of those high performance floors, especially things like, cold storage and ASRS and high racks and things like that. You need a high performance floor and a high performance contractor to do that kind of work. The premium itself is sticker shock to some folks, but people who are familiar with high performance and looking at it in the holistic standpoint of using less reinforcement or being able to pick and choose which reinforcement works best for you, having that impact on the construction schedule, possibly being able to thin the element because it can carry more load, reduction of those joints. You can find that if you're starting from a moderately extended joint system, or especially if you're starting from a high shrinkage reduction mixture, we're going to be cost competitive every time, because you can really push those elements out there and you're dealing with folks that kind of understand that world. If you're going for just a traditional 7-inch unreinforced concrete slab and you're going to look at making that shrink comp, that's a much heavier lift. It can be done, but you're going to have an owner that's going to maintain that building and want to look at that life cycle, long-term cost and factor in the drastically reduced maintenance. Same thing on anything that's in containment or pavements or bridge decks or things like that. You're going to have to be willing to kind of look a little further than just what's my cost per yard, because the cost per yard is not your normal upcharge, but it's certainly worth it and can certainly bring the value to that structure. If you don't have to replace the concrete for centuries instead of years, you're in pretty good shape. And a lot of times where someone's going to consider shrink comp concrete, they are the owner. They're the ones that are going to be required to maintain it. And so it does make a lot of sense. And we have a lot of success in having that conversation because we're starting from a point above just normal everyday concrete.
Yeah. Yeah. This, we talked a little bit about it on the last episode, which would be episode 121 with Derek Cressman from Durable Surfaces. We talked about robotics and these automation machines that require, these high value floors. So if you haven't listened to that episode yet, make sure you go back and listen to that, because this ties in with Lee's episode here. So going back to what I told you to remember is we talked a little bit about, you mentioned a little bit about the powder of today. Have you seen a change between what you all have done in the past as far as the replacement percentages? I think earlier you said you're doing a 15 to 18% replacement.
Yeah. And that's with us on the Type K. A few of the other types, that are covered in our 223 might have a little bit different percentage replacement. I would say as a whole, kind of in the industry, you might find it between maybe 5 and 30%, give or take. That's actually a range we're talking about now. We've got actually an ASTM standard under proposal for the component materials that go in to have our own spec. Our window is that typical 15 to 18. Our process has always been, we'll get the producer materials from that local region into our lab, and we'll run a battery of tests on the front end to determine what is that, potential against that dry and shrinkage, and are we making sure we're hitting our targets, because we've got, we want to stay within all those guidelines. We want to have that engineered expansion and controlled volume change. So we're looking at that on the front end as we get different materials in from different parts of the country, and a lot of those primary, Portland or blended cement sources are changing. We're having to pay a little bit closer attention to that in some regions. I had a project recently where we decided to run the test a second time just to make sure that we had it right, because we wanted to make sure everybody had the quality assurance and felt good about the results in that process. So in some areas we've seen where we've been able to go and use below our target dosage. Our particular baseline has been relatively unchanged for a while. We're evaluating that now to see whether you've got a 1P, a 1S, 1T, or 1L. Is that baseline going to hold true across all those different types? So we're really excited about seeing, where that can land for us going forward. But each and every time, we're still going to do that testing up front of that local materials, because concrete always has been, always will be a regional material, right? And as you're seeing an increase in variability mill to mill, it's even more so. It's just reinforcing that fact. So whereas a lot of people are having to go back and refresh their memory of how to evaluate cementitious powders, because they've just been spoiled, as I was for many years, being predictable without having to run the test, because it was just so consistent. Any change brings about a invigoration of knowledge and having to go back and relook at things. So we're in that process just like everybody else is. But we're not seeing anything that's a drastic change from being like we got to go rewrite standards or anything as far as what our work is. Mm-hmm. So it might tweak a little bit, where we might have used 15% before, we might have to go 17, or where we used 17% before, we might be able to get away with 15 now. But we're doing the test on the front end. That's the biggest thing, which is good for, anybody in the concrete business. If you're going to change a powder, test it ahead of time, and test it as it goes through changes. Test it, because
Yeah.
it's going to change. I guarantee you.
Yeah. Yeah. I wonder, it's stating the obvious, but I wonder how often that actually happens.
Which part of that change in
No.
powders?
We know change is constant. I was talking testing. We talked
Testing.
about that on the podcast, testing your powder.
Yeah. The most of the producers we work with have solid technical teams, and that's the vast majority of my background is being on the technical side of ready mix concrete. And so I may be biased because I love those guys. I love ready mix concrete. I think it's the greatest building material ever invented in the history of mankind, quite honestly. And that's not to say there's anything wrong with precast pre-stress or manufactured concrete products or anything like that. It's just I think the time and the effort, knowledge, skill that goes into running successfully a ready mix operation decade after decade takes a lot of technical knowledge. It takes a lot of market knowledge and material knowledge because it's going to constantly change. Mm-hmm. So to take imperfect adjustments in raw materials and consistently make a product that performs under all the different construction elements you put it under in ready-mix cast in place concrete. It's truly amazing if you think of it from that standpoint. It really is. So I think a lot of those guys are getting really good at keeping tabs on their material. And the ones that weren't and got bit lately are revamping and adjusting and getting a whole lot better at doing more testing in-house beforehand.
Yeah.
Or they should be. But if they're not, if you're listening to this and you're not, and you're one of those guys, adjust. Get ready.
You're playing with fire right now.
Yeah.
Well, that was perfect. I wanted to hit on blended cement, so you already talked about that. So that's kind of the future, right? That's what we're getting into, and it sounds like you all are already doing testing with blended cements.
Yeah, and it's a lot of fun for me coming from the background I did and seeing it on our side, because when you look at things other than what that ready mix producer puts in their primary silo, whether that's a Portland cement or a blended cement, everything else brings its own unique characteristics to the game, right? And the fact that, kind of like slag, we are also a cementitious product. We can kind of elevate that a little bit. So we're looking, that's why when you are asking me about, that contracting the properties and finishability and getting their FFFL numbers, I'm a huge fan of our product, just like I'm a huge fan of slag. I like things that are cementitious, and I don't have anything against ash. I've used them a lot. I love them. Even the, calcine materials out there, or, metakaolin, or I've played around with, rice husk ash in the past, and the ground glass pozzolans and things like that. There's a lot of great pozzolans out there as well. So it's a real dynamic time, not just from the Portland side, but also the SCM side. There's so many different combinations you can look at now. Having that solid technical team, great vendor partners, the ability to look at things in-house for a ready mix producer is critical going forward. It's always been very, very important, but it's critical going forward because their customers are putting more pressure on them just because of the buzz in the marketplace to have a predictable material. And that's always the challenge, keeping it predictable with those changes in raw ingredients. So the fact that you've got really high performance products you can put in those silos to complement that blended material, I just think you're going to see so much advancement in a producer's understanding of how to best put those things together. It's going to be a lot of fun to be in that side of the business. Whereas most people looking from the outside in would say, they don't even want to talk about powders because of pain of transition from one to the other. I look at it as a fantastic opportunity because there's things that need solutions out there that are not our typical problems. This is kind of like a new world we're entering into, and you got a lot of options out there. And we certainly want to be one of them. And I think we certainly can be, because we've just got that inherent, very high performance characteristics in our base material, in our base product. And it's half in typical comparison, half of the GWP impact of what you're putting in that blended cement. So, we've been a highly sustainable material ever since the inception of the product back in the 60s and 70s. Just never knew to count it, But go back and doing the math, our guys put together our EPD and they're like, wow, this is pretty awesome, So we're in the mid to low fours and thinking about getting better all the time as far as our units of global warming potential.
Yeah. That's a whole other episode. We can we can talk about. And I love your attitude about what's going on right now. Some people I get on the podcast, the change that we're going through right now, they're negative on it. And it really, I think it's, your personal beliefs on the whole the carbon reduction, the global warming potential and all that. You kind of have to set that aside and just embrace what's going on right now. And I put it in thinking in our newsletter last weekend when I sent it out. I said, no matter what side of that fence you're on, you gotta acknowledge it's an exciting time in concrete. There's a lot of change going on, and it's going to be interesting. Certainly, what concrete's going to look like in the next 5 to 10 years.
Absolutely, it's going to continue to change. What we've seen in the last year to 18, 24 months is just the tip of the iceberg, in my opinion. And you're right. I think, and it's probably just because of my history and background, so many years of being a field technician and being on the technical side of ready mix, coming up through the business. I learned you got to embrace the pain. You got to embrace the hurt, man, because a problem is just an opportunity if you look at it correctly. And you're right. Your own personal faith and approach and belief to everyday life can kind of help you navigate the world of today with social media and digitization and AI and everything out there. You got to keep perspective, local, and you hear a lot of people talk about that as far as keep it local, keep it real. Well, that's concrete, right? It is a local business, and you have opportunities every different city, every different place, every different job you go. You can look at it as it's just another complaint. You can let it wear you down. And, too many guys, especially we were talking earlier about the testing side of things, and that's the difference in approach we're taking there, trying to be positive and do something about it versus, amplifying the complaint. We want to do the same thing in my CTS world and for our customers and those ready mix guys that I love and appreciate so much, and understand that there's going to be significant challenges, and how can you help? Don't want to sit around the coffee pot or, in the lab in the morning and just have a 20 or 30 minute gripe session over, things that are outside of our control. All right. Here's what we got. I had a boss that his famous phrase, you can only go from where you're at. Well, this is where we are. Right. So you got to make this pour for this guy in an hour or next week, next month. How are you going to do it the best you possibly can for what you have to work with? And that's a challenge that will always be there for Ready Mix. And it's great. It's fun to solve that challenge and learn from it and do it again, and then get a chance to do it again and do it again, and know you could fall on your face at any given time. So be good with it, and be good at it.
Well, like I said, I enjoyed our conversation today, Lee. If folks want to reach out to you, what's the best way?
Either by email, my first initial last name at ctscement.com, L Thrasher at ctscement.com. Or you can find me on LinkedIn, easy enough. Not too many Lee Thrashers out there.
No, that's how I found him, on LinkedIn. All right, Lee. Thank you for coming on the podcast today. And folks, until next time, let's keep it concrete. All right.